I want to introduce Stan. Stan's a registered civil engineer specializing in many facets of water environment. His Bachelor of Science was earned at Lafayette College, and his Master of Science was awarded at the University California, Davis. During his career, emphasis was on municipal wastewater treatment, municipal water supply, water resources, water quality, and environmental regulations. Stan retired back in 2013 and now spends much of his time promoting and facilitating good land stewardship and natural resource conservation. He's a director with Jackson Soil and Water Conservation District, a director with the Rogue River Watershed Council, and a director with the Oregon Association of Conservation Districts. And, my experience with Stan is that he's also been a dedicated land steward, both of his own lands, but also sharing knowledge with others for many years, mentoring people in the land steward program, and visited a lot of properties and helped a lot of folks do good things and do good stewardship. I really appreciate you, Stan. I don't know that you ever retired. You just shifted to doing great community work. So thank you. With that, I'll stop my share and get you guys to Stan. Thanks. Maybe. Sure. There we go. Okay, Stan, you can load up there if you want.
Okay, I'll get my share started here. Okay, well, thank you for the nice introduction. I'm always excited to speak in front of land stewards, and it's a pleasure to be here today. I've given this course a couple of times over the years, probably three, maybe four times. I think last time I did was 2023, so about 3 years ago. I noticed as people were signing on that there are several people who I think have taken this class before. And I'm really worried about you guys because you've seen it before and you know what questions are going to stump me. So you're ringers in the audience here. For the rest of you, please ask questions. I do like questions. I actually like giving this presentation in person. This one's on Zoom because I really like working with the crowd and seeing the people and taking questions and so forth. So we'll do the best we can today to make this interactive. I will stop. I'll go through, perhaps 10 slides at a time and then stop and take questions and then do another 10 and take some more questions. But if Eugene or Wayne see anything popping up there that's like, oh no, that has to be answered right now, they can stop me and deal with it right at the moment. And I believe I'll have time at the very end for more open discussion. There should be a little bit of time left over. So one of the things that my wife and I like to do is we like to go swimming in pristine waters. And my wife says, come on, let's go this weekend. And I say, that means we're going up to the mountains, doesn't it? And it really does. And there's a reason for that. So by the time at the end of the presentation, you'll probably understand why you've got to go up high to have reliably clean waters. Okay, so the introductions here. Thank you, Eugene. That's done. We talked about Q&A protocol, and here's a couple of the big chunks of things I'm going to be dealing with. Physical features, what makes a pond? What are the parts of a pond? How do you construct it and so forth? I'm going to talk a bit about the regulations, can't ignore them. Get a bit into the biology and chemistry, and I'm going to talk a lot about some of the problems and possible solutions, which is one of the themes of this presentation, is that it's not easy. It's more than just digging a hole and putting water in it. There's a lot more to it depending on what you want to get out of it. Oops, clicked the wrong direction. Okay, here we go. If you're thinking about your pond, you really should be thinking about what's the purpose of your pond. Every different type of purpose kind of commands some different design considerations. And here are some of the most common purposes that I see. Stock watering for cows and sheep and so forth. Irrigation supply, so you can pump water out of it and irrigate when your irrigation ditch or other source isn't working. Recreation, I think a lot of people really want to be able to go swimming and bathing in their pond. That's probably one of the hardest ones to make sure you get. Wildlife, aesthetics. Sometimes it's really nice just to look out at your property and see a beautiful pond there and go, ah, how nice. Fish production. Do you want to raise fish for food or just to have them out there? And fire protection, also a source of water for the local fire department or helicopters to drop and pick up buckets if they need to. And again, I want to emphasize that each of these purposes is best met with different pond design features. And we'll talk about some of that as we go forward. Okay, a couple different configurations of ponds to keep in mind. One of the things you can do is just dig the pond into the earth. Sometimes, if you're very fortunate and you have very shallow groundwater, you can simply excavate a hole and the groundwater will seep in and fill it. Sometimes that won't happen, and then you're going to rely on surface water or some other source to get into the hole that you've dug. The other common way is putting a dam across a channel. You've got a small creek or a stream or something like that. You put a dam and hold the runoff back and let it fill up. And with each of those, there's quite a few variations in how steep do you want your sides, how deep do you want your pond, what shape do you want your pond? Do you want it to look interesting and have fingers and much shoreline on it? And again, each of those things will be tied to the type of use. There's also various liners. We'll talk about liners on the bottom of ponds and various amenities that you can add to the ponds, and we'll touch on some of that too. Okay, I am going to talk a little bit about construction of a dam when you're putting a levee or a dam across a channel to hold back the water, or you're building it anyway to hold back the water. The most important thing is to make sure that that dam is very well tied into the native earth and it's very structurally sound where the dam hits the ground. You want to tie it deep into the ground to make sure that it's not going to move or slide or do anything. And the main way you do this is with something called a cutoff trench. Basically, where the dam is, you're going to dig a deeper trench that goes down into hopefully bedrock or at least some very solid ground. And that's how the key and the tie-in is going to be made. So that key or the cutoff trench is then going to be built up with a core, the middle of the dam. And the middle of the dam needs to be made of very strong, impermeable material. You don't want water seeping through it. You don't want it eroding. You don't want organic matter in there that's going to decay and allow things to settle. You want no way for internal channels to form and go through that core. And a lot of this is really dependent upon getting the right soils for construction. The right soils, again, don't have organic matter. They have a wide gradation of very small particles up to silt and up to sand and maybe some gravel in there too for stability. But you want a well-graded material that compacts and is very well and is solid. And you don't want organics in there. Just imagine you got a tree root in there. Well, over time, that tree root may decay. And what have you done? You've just left a hole in your dam. Water can start seeping through there. That's why you don't want organics in it. We're going to look at a few pictures here. Okay, so in addition to the dam, you have to think about each of the different features that are going to control the water. Obviously, the inlet, this is where the water enters the pond. Make sure it gets in there in a nice, gentle manner without a lot of erosion. The outlet where it leaves the pond. Down in the picture on the lower left, um, we've got a riser, and you see those concrete cylinders with holes in them. That would be an example of where the outlet is. The water goes in through those holes, drops down to a pipe at the bottom, goes under the dam, and goes out. That would be your normal way of controlling flow in there. But you also need a spillway. If you get a really big storm, what I just showed you here on the lower left won't work with huge high flows. So you'll need to have something like a spillway that goes around the side of the pond and lets those big flows get away and not go over your dam where it'll erode it and damage it. You also might have pump stations for irrigation and firefighting. You also want some way to drain the pond. So I'm trying to emphasize here that if you're going to build a pond, it is more than just putting a pile of dirt there and saying, I got a pond. More pieces to think about than that. Okay, this is a drawing of what I just talked about here. I'm pointing here at the bottom. This is native earth down here. And this little area here would be the cutoff trench. This is where you would cut into that solid native material. And then this right here is the core. That's where you really need really good material, well compacted. And then these side slopes here can go against the core, over the core, to give it more stability and more mass to the dam. But that's the most important part right there, getting that cutoff trench in the core. You can see they have a conduit going through the core. So over here's the water, over here's daylight. So this would be a way you could drain it. I think they need a valve here. I really didn't like this picture. This drawing over here is looking down on it. And you can see here's going around the outside. Here's the spillway I talked about a little bit earlier. So if the water is coming in really fast in a big storm, you don't want it going over, downside, and eroding your dam. You want it to go up, go over the spillway, and get around. Often those spillways are concrete lined or have real heavy riprap or rocks in there so that they don't get eroded away. But it's a very important feature. I'm going to show another drawing that tried to illustrate much the same thing. And I like this drawing a little better because they have these things called concrete collars. You notice the pipe going through the dam right there? Where the pipe goes through is a real critical location because water can start running along the edges of the pipe and really start eroding things over time. So that's why you have these concrete collars that wrap around the pipe. And so the water just can't go along the pipe and erode it. It forces it to go up and around and down. And that extra length and pushing it through the soil will prevent little channels from going under your dam and taking the whole thing down. This drawing here also shows a valve on the upstream end so you can close it off. Oh, this was another feature I liked of this is riprap right in here. On the side of the dam with the water, waves can often splash against the soils. And so and if you don't have a liner, it really is good to put some riprap, which is basically large rocks or something that's not going to erode. So the water splashes up to it and it's perfectly fine. Okay. Pond, oops. Okay. Pond liners. There's a number of options. Many ponds are just built by compacting the soils. And if you have the right type of soils, you can do it, and you can make sure that it gets tight enough so water doesn't leak through very easily. Again, it depends on having a really good gradation of soil, clays, silts, sands, all in the right proportions. And so if you're going to build a dam, as I mentioned earlier, getting the soils right is critical. And if the dam is big enough, you probably want a soil scientist or geotechnical engineer to go out and analyze the soils you have on site, and figure out, ooh, you got some good soils over here, but don't use these soils, so that when you build it, you know what to take. Or they might even say, your soils are good if you mix in a little bit extra of this before you place it. That's what a geotechnical engineer would do. You can also use imported clay. Bentonite, you hear people talk about a lot. It's a very special, super fine-grained, tight clay. Normally, you want to mix the bentonite into the top, into the soil, so that it really it stops the water from moving through. If you put the bentonite just on the top of your soil, it's just going to get suspended in the water, and it's going to wash away. The other thing it'll do is, if bentonite dries out, it will form big cracks, just like any clay soil will. So that's why you want to get it mixed in and underneath, where it usually retains some moisture, and then it'll have better water holding capacity. You can use concrete or shotcrete, which is a sprayed concrete. I'm not a real fan of that, because obviously it cracks and breaks, and then it's not as good anymore. You can use plastic, polyethylene, vinyl, EPDM. A number of plastics are out there. All of the liners have pluses and minuses. Some are more expensive than others. Some look ugly. I've got that picture up there in the upper right with a plastic liner. Depending on your use, you may not care whether you have to look at that plastic liner. If I wanted a pond for aesthetics, I wouldn't want a plastic liner, because I wouldn't want to be looking at that thing all the time. It just looks artificial and not natural. And it also inhibits the ability to grow vegetation around the outskirts of the pond. So all of them have pluses and minuses. Okay, let's take one more slide. So when you're designing your pond, couple things to think about here. First, do you have enough water? Where's your water coming from? Are you just getting it from the land? Is it runoff from your roof? You got a rain catchment system? Are you using your groundwater well to fill it? And do you have enough water to actually fill it? I don't want to build a pond and then, oops, I don't have enough water and the thing is empty all the time. Adequate water quality. The water coming in there, is it clean? Is it free of nutrients? Is it free of boron or other natural elements that you don't want in there? Access for weed control. You are going to get weeds in ponds. We're going to talk about that later, but think about, if you want to remove those weeds, how are you going to get in there to do it? If fish are planned, are the conditions of your pond suited to the type of fish that you anticipate growing? I'll talk a little bit more about that later. Aeration equipment. Do you need aeration? Do you want aeration? What type of aeration do you want? Access by livestock. Are you going to have your sheep and your cows and your goats and your ducks drink from this pond? mud control and bank stabilization. We talked about riprap earlier. If you really want to use it for swimming, where are you going to get in and out? You want a nice place to get in and out? And then access for fire trucks if firefighting is a purpose for it. So you got to think about all of those things when you plan to build your pond. Okay, let's stop there. Do we have any questions in the chat so far?
Yeah, there's a couple here, and Isabel asks, she says, we purchased a piece of property 2 years ago. It has a large pond on it. We have years of accumulation of leaves and debris, which has formed a sludge on the bottom. Any suggestions on what to do with this sludge? Maybe you cover this somewhere else. I'm not sure.
I will cover it, but I don't actually talk about removing the sludge from the bottom. Um, it depends on how your pond was constructed. If it was constructed with a bentonite liner, I would be very careful emptying the pond and getting in there with a backhoe or a bulldozer and scraping that sludge out, or dredging it with the water in there, because you don't want to disturb that bentonite liner. Same thing with a plastic liner. It's pretty difficult to do, and I wouldn't want to waste that investment. Um, if it's just earthen, you could dry it out, drive in there with a cat once it dries out to support the cat, or a backhoe or an excavator, scrape it out, and then recompact all the soils that are in there to make sure everything is real nice and tight again.
Okay. And CJ asks, any thoughts on Damn It? And I don't know if that's a product or
I'm not familiar with that. Maybe CJ could explain what he's talking about.
CJ also, mentioned early in the meeting that he had a problem with the weed infestation in his pond, and uh, it was maybe wants some help identifying the plant. CJ, you can email me that picture, and I'll put it in front of the correct people to give you an ID if we can. You might also consider iNaturalist if you've never used that. It's pretty good at identifying plants if you've got a live specimen or photo to work with. But feel free to send that my way, and I'll put it in front of some aquatic weed experts if I can identify it myself.
Anything else there?
Yeah, CJ popped back. He says, sure, it's the powdered stuff that you can supposedly drop into the water to seal off leaks.
I have not studied that product. To me, it would seem like it would be something that's very fine grained and seeps into the soil and seals it off. Um, I would be very, I'd want to know how the manufacturer says you're supposed to apply it. Are you supposed to drain the pond? Are you not? How do you get it evenly distributed over there? I would also be concerned with the size of your leaks too. If you've got very small, slow leaks where something you're putting in there can infiltrate those small pores and seal it up, I think it has a better chance of working. If you've got some pretty good sized channels going through there, size of a pencil or something like that, I would be really skeptical about something like that working.
Dan, we have one other one. Brian asked, does aeration reduce weeds?
I got a whole slide on that. We'll get to that.
Great, thank you.
Okay. So the next, going back, I talked a little earlier about, do you have enough water for your pond? Go into that a little bit more here. You can estimate the amount of runoff from your watershed. Real crude method is, okay, you've got 1 acre, and say you've got 15 inches of rain on that 1 acre over the course of a year. You can calculate, okay, that's how much water falls on the watershed. But then how much of it actually makes it to the pond is the more difficult part. If you have really loose soil, sandy soils, a lot of it's just going to go down to groundwater and miss your pond. If you have a lot of vegetation, it's going to hold it back and it's going to use it itself. If you can have some evaporation and won't make it there. So if you have a watershed, you could have a wide range of how much of that water makes it to your pond. It could be 5%, it could be 90%, just depending on the characteristics of that catchment area. Now, impermeable surfaces, like how much are you going to get off of your roof or off of your barn and catch it in your gutters, you can get a much more accurate estimate of how much water you've got to fill your pond. Don't forget pond losses. Unless you have a really tight liner, you're going to get some percolation into the ground and you're going to lose some of it. Evaporation is probably the bigger loss, though. You can have up to 2 feet or more of evaporation off of the surface of a pond over the course of a summer. And that can really draw down a pond. One thing you can do if you're good with numbers, you can actually go and perform a water balance on your pond. You can estimate the size of the pond, how much surface area you've got, how much flow you've got on, how much evaporation is coming on, how much are you going to withdraw from the pond for your own uses. And you can sort of march through month by month to estimate whether you've got enough water for your pond. That's a little trickier to do, and it can be done. I've helped one land steward do that in the past. Okay, I just really like this idea here. Another diagram. Cows going into a pond, they can create a mess. They stir up a lot of mud, can destabilize your banks. I just don't want them in there if I'm going to use it for contact recreation. So here in this case, they had their outlet and they had the pipe running through the dike, and then they had a valve that they turned, and when they opened the valve, it filled a trough for the cattle outside of the pond. That way they could use the pond to water them without having to let the cows go to the pond. I just thought that was a nice idea. Okay, so who's your regulator? The big regulator for ponds is Oregon Water Resources Department. The Oregon Water Resources Department is the one that employs the water masters throughout the state. I hear a lot of people say, oh, it's the county water master. Well, it's Oregon Water Resources Department who put somebody in our county, but it's not Jackson County is not their employer, it's Water Resources Department. But you may also have others depending on what you're doing. Department of State Lands and Army Corps of Engineers. If you're doing any fill or placement of soils within a waterway, they get involved and need permits. Department of Environmental Quality can get involved. If you're dealing with confined animal lagoons, ODA gets involved. And if you're working in a riparian corridor, we don't want to forget the Jackson County Riparian Ordinance. So according to DWR, there's 2 different types of ponds, and it's based upon size. One of them is called statutory, and the other is non-statutory. Statutory is the bigger one, and if it has more than 9.2 acre feet, or it has a depth of more than 10 feet, it's called a statutory dam. Those are the big ones. You can also have a bulge pond and an exempt pond. Bulge pond is typically seasonal and used for irrigation. An exempt pond is one of the few exemptions where you don't need a permit for it. But both statutory and non-statutory dams do need permits from Oregon Water Resources Department. Okay, if you haven't heard the term acre feet, this 9.2 acre feet, which I used here, an acre foot is the amount of water that would fill an acre to a depth of 1 foot. So 9.2 acre feet. If your pond is 1 acre in size and the average depth of 9.2 feet deep, you're right on the borderline between these two types of dams. Okay, you do need a water right. And there's a couple different, there's a primary water right, which allows you to appropriate and store water, i.e., you can take it out of a stream, you can take it out of a ground, and you can put it in your pond if you're using a pond. Then there's a secondary water right permit that actually allows you to take it out of the pond and put it to use. So there's two permits here that are applicable. Once you have your permits, you have a proving up period, and you have to show Water Resources Department that you actually did it and you're actually using the water the way you said you were going to when they gave you the permit, and you have 5 years to do it. Once you think, yep, we're going, everything's working, you get a certified water rights examiner, you get out there, they verify it, information gets turned into Water Resources. And now you have more than just a water rights permit, you have a water rights certificate, which says you're good to go from here on out, as long as you keep doing what you're doing. Okay, statutory dam requirements. The design has to be prepared by a registered engineer and approved by the state. Again, there's usually the primary and secondary water right permit. And if you have one of these big dams, you are obligated to maintain and repair and protect the dam, because they're big enough that if they fail, they can hurt downstream property. And that's why these bigger ones require more scrutiny. And on a statutory dam requirements, the state will come out and inspect those from time to time. Non-statutory dam, you don't need to have a registered engineer plans, but you're still going to have to put together some sort of drawings saying what you want to do and apply for a permit. So this is an alternative water right permit application. It's a little less intensive, and they have one of them if you're using surface water and one type if you're using groundwater permit. If you got any questions about this, the place to go is to your water master, and they will definitely be able to point you in the right direction for how to get through the permitting process. Bulge ponds, these are used only for temporary storage of irrigation water. But if they're of that statutory size, they're still going to need to be designed by an engineer. I haven't seen any bulge ponds that are that big in my running around. But if you do have one, it would be required. Permit isn't required for a bulge pond, but I would still go out and talk to the water master and explain what you're doing just so they know and you don't get questioned down the road. I think that would be a good practice. Common exemptions why you may not need a permit. Stock watering, you need a primary water right permit for your pond, but you don't need a secondary water right permit to use it, because stock watering is an exempt use under state law. So is rainwater collected from an artificial impervious surface, like the roof of your barn or the roof of your house. If you're doing that, you don't need a water right permit, and you can go ahead and do what you want with it. However, even if you collect it from your roof and it's over that statutory size, again, it'll start falling into that size that you need to have engineered plans for it. What about those really small ponds? I've never gotten a clear answer on this from Water Resources Department, water masters. Those really small ponds, like your koi pond, does it need a permit? When I read the regulations, technically it does. I don't see a de minimis size in there. Is the water master going to come after you because you've got a koi pond out there? Probably not. They don't care about it that much. I think it's one of those things they just let it go under the radar. Okay, let's stop there. Anything else, Wayne or Eugene?
Yeah, we've got a couple questions in the chat. Muriel says, my pond was made about 100 years ago, so I don't know what it was made of or how it was made. It fills from an underground creek, I think. I'm not sure of how to make it more secure. So far, I haven't noticed any leaks, but a grow house on the property next door cut away about 10 feet of the bank, leaving only about 10 to 15 feet of horizontal bank. So I think she's asking, is there another way to make it more secure? And I'm thinking that's, if we've got eroded bank, we probably need to look at it, or maybe have an engineer look at it, especially depending on the size of
Yeah,
the pond.
yeah. This is one I would I would be reluctant to give advice on that without actually seeing it and seeing what the situation is.
Yeah, like Stan mentioned, depth and size could be a factor there. Nora has asked here, are there other ways to compact the soil around the walls of the pond besides using an excavator bucket? My irrigation pond was dug last year by a friend with an excavator who no longer has the equipment, and we didn't think to have him compact the sides of the pond. I
Well,
noticed a loss.
yeah, I think that an excavator, yeah, it can pack it down. It's not the best at compaction. I would suspect that a cat driving up and down would do a little better on that. Um, the best thing to compact it is something called a sheep's foot roller. And this is a big piece of equipment that has little teeth on the end of a roller, and it goes down and really gets things compacted tightly. I don't know how many people have those. People who construct roads, they have those. But they're probably not around just with rural landowners very often. But a sheep's foot roller is the best.
He asks, what if water use fades, rights lost? So I think if you stop using if you're if you're not using your irrigation pond, or you're not using it, uh, do your water rights get lost?
Um, you can. Um, Water rights in Oregon have a provision that if you don't use your water um, for a period of 5 years, every 5 years, you don't fully use your water right, it is subject to forfeiture, which means that if somebody protests or complains and takes it to the Water Resources Department, they can take away your water right in the amount that you did not use. So that would be the dealing with the quantity of water. I don't think they could really take away your pond, but they could take away the amount of water you're allowed to put into your pond.
We had a question from Zachary. What makes a pond a reservoir? For some reason, on my water rights certificate, it calls it a reservoir.
Different terminology, same thing. Reservoir is used in statute. Ponds are just more common. Everyday people use it.
Thanks. Okay, that's it for now.
Okay. Aquatic plants. What do they need? Just like any other plants, they need water. They need carbon dioxide for photosynthesis, and they need oxygen for respiration. Remember, photosynthesis happens during the day. Most of the respiration happens at night. They need sunlight. They need nutrients. They need the temperature to be right, and they need the ability to reproduce. So if you're going to deal with plants in your pond, whether trying to get them to grow or to keep them from growing, you need to think about all of these factors. And I'm going to go into those a bit more. Also think about the different types of aquatic plants. Here I've got 4 different types. Over here I've got algae. just very, very small plant, basically, that are suspended in the water column. Down here, these are submerged aquatic plants. They grow off the bottom, and sometimes they don't even reach the surface of the water. Then there's floating leaf plants. Sometimes they're rooted into the ground and they go up and float. Sometimes they're not even rooted and they just float around at the whim of the wind as it pushes them around a lake. And then you have shoreline plants that stick up above the water column around shorelines. I just show you this pond just as a reminder that things grow in ponds. This is a little tiny pond that it is dry 6 months of the year, not a speck of water in it for 6 months. But sure enough, when the fall rains come and it fills up, there's still enough of that algae seed or whatever it needs to get growing again that it starts right back up as soon as the water gets in there. And a lot of times it happens in the summertime, but here this picture was taken on February 15th one year. So it can happen pretty early and pretty quick once water gets into a pond. Okay, the good with plants, habitat for all sorts of animals. It's a good source of food for some animals, depending on what plant you're talking about. Contaminant removal. I think most of us know that wetlands, for example, are a great way to remove contaminants from water. And obviously, plants can be attractive. The bad with plants, they can cause wide fluctuations in oxygen and pH. Remember, I talked about photosynthesis makes oxygen and the respiration uses it. So as those plants basically breathe during that diurnal cycle, the oxygen levels in the pond are going up and down. And correspondingly, that affects the pH in the ponds too. They can impede navigation, keep you from boating, discourage recreation. I don't want to go swimming in a pond with a bunch of weeds in it. If you're using irrigation systems, they can wreak havoc with that. If you have channels and you're trying to get flow through them, they'll slow down the flow. They can be ugly, and sometimes certain types of algae can be toxic. I'm going to give a couple quick examples here of invasive species. There are quite a few more invasive species, and if you really want to get into them, I would suggest going to Oregon Invasive Species Council. They have some information on aquatic weeds. Oregon Department of Agriculture has a list of weeds that are of concern, and within that list is aquatic weeds. But I've come across a publication that I really like. It was put out by Benton Soil and Water Conservation District. Benton is the district up around in the Corvallis area, and you can go to their website, but they've got a identification and methods of control for aquatic invasive weeds. And I think it's the most useful document I've seen. So if you're concerned about it, go to Benton Soil and Water and get their document on invasive aquatic weeds. Okay, so here's one, South American waterweed. It's a rooted, submerged perennial, can get pretty tall. It reproduces by plant fragments. So if you go in there and try to cut it out and you leave a bunch of fragments that float all around the place, those fragments are just going to start resprouting again. You're actually helping it spread by doing that. It's widespread in Western Oregon, and it got here from home aquariums. Many of our invasive species got there that way. Okay. Here's another one that grows on the banks, purple loosestrife. Grows on the banks, pink and purple flowers. Big rhizomes, big root mass where it grows. It can reproduce by seed or by the rhizomes. Once again, it was brought over as an ornamental. This one dates all the way back to the 1800s, and it is widespread throughout Oregon. Here's another one of a different type, parrot's feather. This is a floating mass of weeds that grows near the surface. It's also widespread in Western Oregon. Really likes waters that are very high in nutrients. And because it's floating, it obviously likes slow moving or still water. You're not going to find it in the middle of a rushing river. So I just threw in 3 of them, but there's many more out there. And again, I'd refer you to those resources I mentioned. Talk a little bit about the, well, let's stop here. Anything on weeds?
Um, Not specific to weeds.
Okay. Or anything else that's crept in?
Yeah, right after we left the last segment, Corey asked, my pond is made from shotcrete. It is leaking. Would it be a good idea to line it with plastic or start over?
uh, I think either way, it's going to be a big project. If you're going to line it with plastic, you're probably going to want to get a contractor who is familiar with installing plastic to get it done professionally. And I would ask for their recommendations on whether they would want to remove the concrete first. If there's any sharp edges on it, I'm gonna suspect they want to get it out of there because you don't want anything that could tear your plastic liner.
CJ asked, what do you think about using fish for algae control, such as grass carp?
Um, I'll get to that later. I don't think grass carp are permitted in the state yet. You'd have to check with Oregon Department of Fish and Wildlife to see whether they're actually allowed.
Nancy says, I'm relatively new to Oregon and don't know if blue-green algae are a big problem out here. In Utah, we've incorporated blue-green algae ID into our statewide citizen monitoring program. This provides the state DEQ with some early warnings since they were stretched thin. I think we do have algae in Oregon.
We have quite a bit of blue-green algae in Oregon, particularly in our reservoirs. Um, and it can be a real problem. It has shut down drinking water plants in Oregon because of the toxins that it produces. I mentioned it a little bit later here, but yes, it can be a problem. And if you think you have blue-green algae, you can take, and you think you have toxins, there are laboratories that can test for the toxins to see whether they're present.
Um, let's see. Muriel asked, one of my huge willows fell in the pond in a recent windstorm. How should I deal with it? It's a third of the size of the pond, which is only about 4 feet deep. Also has emergent plants, big ones. Willows have been 50 to 75-year-old, so it's huge.
I would say it depends on the use of your pond. If the use of your pond is purely wildlife and you want habitat for things to hide, it may not be such a bad deal to have it there. Um, Otherwise, if pulling it out of there with some heavy equipment isn't going to damage the sides of the pond, then you might consider doing that too.
Um, Sarah Roberts with Denton Soil and Water posted a link in here. Might be, I'm not sure if it was to aquatic weeds or another manual, but that link is available. Thank you for that. Um, Rebecca asked, so what about duckweed and maintaining natural ponds with invasive plants that are already growing?
Um, I've often wanted to see somebody or try to use natural wetlands to control their weeds. And I think they can, but you're going to have to, the pond has to be designed to circulate and move the water in a way that the weeds can actually capture and treat the water. It's almost like a separate channel that you recirculate through if you're going to do that effectively.
Jerry says, does barley straw inhibit algae growth?
Um, I've heard good reports of it. I haven't tried it myself, but I've heard that it can. Um, I'll talk about that a little bit later here, because it will just it can produce ozone as it decomposes, and that ozone will kill algae. But the algae will just go to the bottom of the pond, and they will decompose later and put the nutrients right back in, and you'll still end up with the same problem down the road. So it's a short-term fix.
I guess I would just chime in too and say that, one problem I've seen with aquatic weeds is that they may not seem a huge problem in your pond, but then eventually your pond washes out for some reason in a, storm event or whatnot, and those weeds end up in the rogue. That's how a lot of our aquatic invasives made it into our watershed from ponds.
Yeah, thank you for adding that. Okay, let's move on. I'm starting to watch time a little bit here. I'm not going to go through this food web, but just remember that nutrients go to phytoplankton. They get eaten by zooplankton. They eaten by smaller fish, get eaten by bigger fish. The point here is that the cycle of nutrients and everything that's in a pond, they're all interrelated. And I'll show the same thing again here with nitrogen in this case. Nitrogen can enter the water, sometimes detritus, just decaying organic matter, or sometimes you put fertilizer on your lawn and the rain hits it and carries the fertilizer in, or cows are urinating in the water. All of those different ways add nitrogen in here. The nitrogen usually comes in the form of ammonia. That's the most common, but it can then go to nitrite and nitrate, which is then consumed by the plants, consumed by the other organism, consumed, die, go to the bottom, decompose. When it decomposes, that releases the nutrients again. The point here is that once nutrients get into your pond, they just circle around in different forms by and large part. They don't really leave. So over time, most ponds build up more and more nutrients. And that's why ponds age and get more and more algae over the years. I'm going to blow through this one, but it's basically the same thing. Phosphorus does the same thing. It just circles around in the pond in different forms over its life. And this leads to the trophic state of ponds. This is why if you want to go up swimming in a clean lake, you're going up into the mountains, because there is not a lot of nutrients running off into those high alpine lakes to start this whole eutrophication process. In limnology study of lakes, they usually classify the trophic states of lakes oligotrophic. That's like the Crater Lake type of thing, really clean and clear. Mesotrophic, a little more algae. Eutrophic, you got a problem. And hypereutrophic, I don't know if I'd even want to touch those ponds. You can measure the state of the trophic state of your lake. You can measure the amount of phosphorus in it. That would give you an indicator of how much nutrients and how eutrophic it's gotten. Chlorophyll A is a measure of how much suspended algae you've got in your pond, another way to do it. Or you can simply look at the clarity or the turbidity with it. But over time, almost all ponds will go through this state. And from a very young pond, it'll be clean and it'll just keep moving to higher levels of trophic conditions over time, unless you do some sort of remediation on it. And it'll happen at different rates. Sometimes it may take, centuries or longer for ponds to become eutrophic. Other times it can happen really quick, just depending on what your nutrient load is. Why does oxygen matter? Well, plants convert it, CO2 to oxygen, but they also respire it. It's needed by aquatic animals. Fish need it, plants need it. So it's important to have good oxygen in your water column. It's also needed for decomposition by some fungi and classes of bacteria. Also, without oxygen, um, ponds will start to stink more. Oxygen levels can cycle up and down over 24 hours. You can have very high oxygen during the day and then have a pond that's oxygen deprived at night when all of it's getting taken up. That can wreak havoc on living organisms in your pond. Phosphorus, oxygen can precipitate phosphorus under certain conditions and take it out of the water column and drop it down into the sediments. That's well and good, but I believe that it's going to recirculate eventually from the sediment, so it's not really gone from your system ultimately, unless it gets buried deep in the sediments. Colder water holds more oxygen. That's why trout like cold water. You can aerate your ponds by a number of means. Actually, just wind blowing across the surface of your pond aerates it. Waterfalls, if you're in a river, for example, waterfalls do a wonderful job of aerating streams. You don't have that in a pond, obviously. Over here, you can see this is a surface aerator that's just out, and it's just a big mixer on the top of a pond, and it just runs around and scatters the water. That can do a pretty good job of aeration. You can put sprayers that spray it up and let it fall down. There's a number of ways to do that. Warmer temperatures is important. Plants grow faster, bacteria use more oxygen, then the water won't hold as much. So warmer temperatures are detrimental to ponds. You're more likely to have stagnation and odors in warmer waters. Light, huge factor. So let's just say you have a dense canopy of trees over your pond. You're going to be shading it, and that shading will prevent some of the growth of plants in there. It'll slow the plant growth down. Now, if you have an abundance of suspended algae and it makes the water cloudy, what that will do is it'll keep the water from hitting the bottom of the pond. So if you have certain types of plants that like to germinate on the floor of the pond and grow up, if you have a bunch of algae in there, they won't do so well. If you have a surface covered with floating plants, like a water hyacinth or something, that'll prevent it from getting down in getting into the water column. In that case, you probably won't have a lot of suspended algae because you're shielding it from the light, and you probably won't have much stuff growing from the bottom. And then obviously, if you have clear water with direct sun, everything's going to be competing for it and wanting to grow. Okay, why does flow matter? If you've got good flow through your pond, you're basically going to be flushing things out. The example there on the right, I've got a 1,000,000-gallon pond. Well, that's a few acre feet, give you an idea of size. And if you have 10,000 gallons a day coming into the pond and going out, that means you're taking 100 days to replace that water volume in that pond. That's not very much. You're not really cycling things very quickly. Think about algae growth. If algae in the summer can double their population in 2 days, but it takes you 100 days to wash them out, that flow through there is not doing anything. That algae just has free reign to grow as much as it wants. Mosquitoes, they breed in standing water. Strong association with plants. Plants actually hide mosquitoes from predators. Different types of mosquitoes. Some reside on the surface, some attach themselves to the stems of plants. If you got mosquitoes, go to Jackson County Vector Control District and get some advice on them and what you can do. Mosquito fish is one common approach. Okay, weed control. You can try to draw down your pond, dry it, let it freeze in the winter. Remember that frog pond I showed you earlier? It's probably not going to do that much. It'll get rid of some types of weeds, but it won't solve most problems. Physical removal, you can hand pull it. If you have a small enough pond, you can use rakes and drag lines to scrape it off your bottom. But remember that one weed I mentioned earlier, where if you break it and you leave fragments, they just grow into new pieces. So be careful about what technique you use depending on what plant you're dealing with. You can dredge it, you can use mechanical cutters. You can shade it. You can put covers on your pond. Some people even put dyes in their pond to keep the water from light from going down into the bottom. If you have a problem with plants that are rooted on the bottom, you can put mats on the bottom, and the plants won't grow right there. You can also use biocontrols, insects, grass carp. Somebody mentioned that earlier. That one you need to check with ODFW. I'm not sure that you'd be allowed to put it in a pond here in Oregon. And you can use chemical control. Just a few photos of weed control, a rake. Here's a little device that you basically stand on your dock and you throw it out. It sinks to the bottom and you pull it in, and these little blades are little knives and they just pull through the weeds and cut it as you haul it in. Here's somebody trying to do something with a boom on the front of this barge, going in and scraping it and lifting it and dumping it for big projects. We mentioned algae, different types, green, blue green. Blue green are the cyanobacteria. They're the ones with that create the toxins. The algae can be dispersed. It can be filamentous, different forms of algae. There's the blue greens releasing toxins. Algae, the important thing here is they are subject to growing quickly, taking over, and then rapidly dying off. And it's this decay that when they die off in the winter, they can fall to the bottom. And that decaying, depending on the conditions of your problem, that can deplete the oxygen, lead to fish kills, and it can also allow odors, hydrogen sulfide, to come up from the bottom and create bad odors. So for algae control, the key is keep out nutrients. Try as hard as you can to keep nutrients out. Don't put fertilizer on a lawn right next to a pond that flows into it. Aeration, maybe. I don't believe that aeration really kills vegetation. They need oxygen. You can rake the mats, you can pump and filter it. You can use copper sulfate, example. Here's an algicide. If you throw that in there, it basically kills the algae. But again, I don't like something like copper sulfite in most circumstances, because the algae just dies, goes to the bottom, and you haven't got rid of the nutrients. So those nutrients are still in there, ready for the same thing to happen next year. Sodium carbonate peroxyhydrate, it basically forms hydrogen peroxide that acts as an algicide. That's the exact same thing that barley straw does. When barley straw decomposes, it forms hydrogen peroxide, and that kills them. You can get manufactured bacteria and enzymes. I hate to call them snake oil salesmen, but they can work of breaking down organic matter in your ponds, and they can give you some temporary relief. I just worry about the stuff is going to drop to the bottom again and go right back into the cycle, and the nutrients are still there, so it's going to happen again. And so over time, you become addicted to these bacteria and enzymes that you have to purchase from some company. They can provide relief, but not permanent. Okay, on fish. You must match the fish to the pond characteristics. Thinking about the type of vegetation, thinking about the temperature, oxygen levels. Diversity of habitat is generally beneficial. If you have a dense monoculture, basically one type of crowded plants, you're probably going to get a proliferation of small types of fish. You'd probably have a whole pond full of small bluegills if that's what you were trying to grow. Bluegill do like vegetation in all life stages, from young to old. That's different from largemouth bass. If you want to grow some really largemouth bass and have some fun fishing for them, you need some open water. Their young rear really well in the weeds, but when they get bigger, they want to be in open. They need open spaces to forage. Trout, if you want trout, you better have cold water and you better have a lot of oxygen. They're very sensitive to both. And trout, they can work well with vegetation, but not too much. Okay, my pond leaks. What should I do? Well, make sure that catastrophic failure is not pending. If you see a pencil size or larger trickle going right through your dam and coming out the other side, to me, that's worrisome, because that hole will just get bigger and bigger until one day the whole dam can fail. If you're starting to see those types of signs, you really need to drain it and rebuild it. And if your soils aren't right, you may need to put in an artificial liner. My pond is leaking. What should I have done? Well, it may have been caused by varmints, squirrels, rats, anything burrowing in there to start little tiny holes and start weakening the dam. Managed your vegetation. It's not a good idea to have deep-rooted plants on your dams. Those roots will work into the soils, and at some point the plants die. Once the plant dies, those roots can decay, and you're left with a hole that can ruin your dam. So don't put deep-rooted plants on your dams. But it is good to have shallow-rooted plants, because they can prevent erosion, which also can be a problem. Inspect your flow control features. Make sure your spillways are working. If you have drains on your pond, make sure they're working. The regular overflows, make sure they're working. Just make sure everything works. And that's the best thing you can do to project the longevity of your pond. If you're going to hire a contractor to help you with building or maintaining a pond, make sure one of you, either the contractor or you, knows the regulations, or you get some outside help to understand the regulations. If you're going to invest a lot in a pond, you should make sure that it's done legally and correct, so you don't run into problems down the road. Get reference checks with the contractor. Ask them a whole bunch of questions. Hey, who's going to do the soils evaluation to make sure I've got that good gradation of soil to construct my core? What type of compaction equipment are you going to use? Are you just going to compact it with your excavator, or do you have a sheep's foot roller? Can you get one? Do you think I'll have weeds? Let's talk about how I get in there and control weeds if I think I'm going to need to. On and on, whole list of questions. Make sure you vet your contractor thoroughly. Hey, we made the end. So however much time we've got left, we can deal with more questions and discussion.
Muriel asked about, what kind are mosquito fish, and I think she may have been wondering, which type of fish. You want to speak to that at all?
Mosquito fish is a type of fish that's named a mosquito fish. And if you go to the vector control district, I suspect they can tell you how to get some. They're small fish,
And
half an
they
inch
can talk
long. Yeah, pretty small.
warm water fish too.
Yep.
Um, Sego asks, are there shallow rooted native shrubs that you would recommend for a dam?
I don't have any firm recommendations. I would tend to put grasses on them myself just to be sure. Go to your local nursery. You can probably find some natives that aren't too deep.
If the pond maintains its water level most of the year, spirea could be a potential. It's not real deep rooted and has fibrous roots.
Okay.
Um, Tom asks, what are your thoughts about turtles in ponds? Are they viable and positive factor?
I like turtles, especially especially the native ones. Um, and I don't think they might burrow into the sides, but I think there's a lot of good in turtles too.
Um, Sego asks, I was told that if you see a minor leak in the dam, that it's a clear and therefore not moving sediment, not to worry.
I'd still maybe not. If it's moving through there and it's surrounded by very hard, non-erodible material, you might be able to get away with it, but you just don't know.
Um, Sarah Roberts says also native willows, wapato, and monkey flower as potential plants for around your pond.
Oh, good.
And Sego asks, are meadow voles much of a concern or muskrats?
I would worry about any of those burrowing animals that goes deep into the things. I would make sure don't let them get into your dam.
And probably definitely beavers. Keep an eye out for them.
Yeah, and if you really have a serious problem with something like that, you may want to put a pretty heavy layer of riprap over your dam to help prevent some of the burrowing.
CJ also says, don't forget nutria. He had a
Yeah.
huge problem with that, and they are present in Oregon, so we can get them sometimes. I don't think they're here, but the potential's there.
Yeah. Yeah.
Jerry asked, the dike on our pond was built top of a gravelly old stream bed. Would compaction at the foot of the dike stop the leak it's always had there?
That's where you need to, if a cutoff trench was not dug in below that gravel, um, then just compaction of the dam isn't necessarily going to do it. You need to make
On that
sure
note,
it's all, make sure that porous spot is totally cut off.
on that note, I had a question for you going back to the very beginning of the presentation. You showed those diagrams about the construction of the dam and the core. And I wondered, is concrete a viable material for the core, or is there a reason to stay away from a sort of a concrete sill in there and favor clay or something else?
It can be because it's very hard, it's very stable. Um, yeah, it might crack and you might get some pinholes through it, but again, that's not in that case, it wouldn't erode much further than those cracks. If I was to do concrete though, I would be wondering how expensive is it? Could be very expensive for many people. And secondly, I would want to make sure the outside of the core, the embankments around the outside, I would pay a little more attention to making sure we've got good soils and well compacted out there, to make sure it stays off of any cracks that develop in the concrete core. But I think it's a viable option.
Okay. Well, I think that's the end of our questions, unless anybody else has anything they want to pose here in the last couple of minutes. I'd like to thank you for this, Stan. I know you've given this presentation before, but this information is always good to hear and to think about. And there's lots of thank yous coming in because I think our patrons tonight are also feeling the same way and really appreciating you.
Okay. Well, good. It's fun to do it, and I hope everybody got what you need. I do try to help our land steward community. So, if you're a land steward out there, you know how to reach Eugene, and Eugene knows how to reach me. And so we'll go from
Thanks a
there.
lot. Yeah, thank
Thank-
you. And just for folks, so you know, this was recorded. You will get a link to the recording. You can use that link to view it. You can share that link, and that'll come to you in an email from Ideal Logic. So keep an eye out for that. And we'll see you on the next community class presentation. Thank you for coming tonight.
thank-
All right, I'm going to go ahead and stop recording.